What we need is an interface the user can use on-site to access information related to specific objects by clicking or, in this case, tapping on them. So if the user wants to see section drawings related with the wall, they just tap on it. If they want to see information related to a specific object, they just tap on it. So, you know, the data that the user needs is just one tap away. So instead of searching through a set of documents and browsing all this data, they just tap on a certain object to find information about that.
For everything that Lee said to be possible, we need three things. We will need a 3D model. We will need all the data associated to the objects inside of that model, and we'll also need a visual representation of reality. And then we'll have to have a way to align that visual representation with the 3D model, and so we're going to do that with 3D panoramas.
You see there's relatively few elements modeled within this environment, just a few beams and pumps in a facility. We've also got an architectural drawing that serves as the floor to give users perspective. And so as you'll see, you're presented with a UI here where the user can add their first panorama. So one of the first things we're going to do is we're going to click this new panorama button. We're going to select an equirectangular photo panorama, which will then be cut into 6 individual images, and a cube will be created from that. So the user has to give the model a name. This will serve as the cell element name within the model. So upon giving it a name and clicking the preview, the user is presented with the 6 images that make up the cube, so they can browse through those and verify this is the correct panorama and to get a feel for what it looks like. So you'll see all the faces. So upon verifying that process, the user clicks OK, and they'll then be presented with a new form. They'll also have the option to place the panorama, roughly align it with some controls, and then in the future they'll have a fine adjustment process. So the first thing we're going to do is go into the placement. So you'll see that the model shifts to a top-down view that allows the user to place the panorama. So being roughly familiar, we want to choose the location where the picture was taken. So upon choosing that, we click and we see that we're now immersed within this model. So one of the next steps here is the rough adjustment process. So we're going to bring up our controls here again, and we're going to go into the rough alignment. So you'll see that the user is presented with several controls to manipulate and move the cube and camera together. They can adjust the increments of movement by various values. They can adjust it by minor or major increments or hand key in their value. So you'll see that we can move it about the X, Y, or Z axis. And it's important to note here that only the cube and the camera are moving to maintain the integrity of the model. So you can see there's various movements needed to create that alignment that gives that user the rich visual experience. You also notice that this is a vast improvement over the current process, and the user has immediate feedback while being immersed in this environment. So one of the next things we're going to need to do here with this model is we're going to need to rotate it. So we're going to start in 45-degree increments. So being familiar with it, we know that it needs to be rotated this much. The user can also rotate it on its axis, roll it forward, roll it left, to get it in the correct position. So as we get closer, we're going to drop those increments down. So as you can see, this is what it would look like to be in that process. User requires to be somewhat familiar with the model, but it's a much more intuitive process, and it's a lot easier to gain that alignment. So one of the next things we're going to do is we're going to skip into the finished product, what it would look like in a manual environment. And as you can see, we've got certain view properties to display and show the model elements right now. So you can see that we're very closely aligned within this process. All right. So after the user has done with their rough alignment, they would then click OK. In the future, they would be able to choose this fine adjustment option. So the goal for this fine adjustment would be to select a point in the model like this beam and the point in the image and draw a line segment. So upon doing this 6 to 7 times, the user would then be able to click the Align button and the photo panorama would shift into place. So again, seeing that point on the model to the point in the image. So once the user has completed that, they can lock the view down, lock the panorama into place. and then go back to the main UI. You'll see that then the cell is populated in the grid with your panorama, its ID, and its visibility. So one of the next things we're going to show you is what it looks like when you come into a model that has a visible panorama. You'll see that we can't see the model. So we've added the feature here for the user to hit the select button and be taken to the view within inside their panorama. So, one of the pain points in this process was not being able to continue editing your model with that panorama once it's live. So we've added the ability for the user to turn that cell on and off so they can continue editing their model and updating it as needed. This really provides a more efficient and user-friendly process that gives you real feedback and allows you to achieve a more successful alignment. And that was one of the main goals of this project, to set out and figure out how can we achieve this alignment. But one of the next steps was, okay, now that we've got this rich visual model, how do we supplement it with the data that users will need in the field?
Okay, so the end goal of this whole process is giving users an enhanced visual library of information. It's great to give them the ability to access external data sources, such as EB or project-wide data, but they really need the ability to add their own data on the fly within the application without having to exit MicroStation and go in and edit the database. So for our introduction to programming within the MicroStation environment, we actually developed an add-in that will allow them to do just this. And it will pull up a list of predefined schemas that we already have with our model. And using these schemas, we're going to select one, and we'll be given a list of classes within those that hold our information architecture. So from here, it's as simple as giving a key and a value and selecting the object that we want to paint this on. And you'll see that it gets added right within the element information already generated in MicroStation. So you'll see that you're able to supplement the information you get with, right now MicroStation generates the XY coordinates, or it gives the origin of certain elements, but you don't get any real-world data associated with that. So that's what our add-in worked to address.
So you can see this, yet again, provides us with another opportunity to supplement our model with the rich information. So to bring this project full circle back to the Bentley Paint Overview application, we feel like we've created a more efficient process from the user to get from a basic model to this rich visual environment. That being said, there are many opportunities for the future.
So the next step in the future process of this project would be an automatic alignment functionality, and this would be equivalent to that fine adjustment that Justin highlighted in the demonstration earlier. So this automatic alignment process would allow the user to connect points and line segments from points on the model to its corresponding points in that panorama. So the user would connect in between 4 and 7 line segments, and after they connect these line segments, they would use this toolbar over here on the right to kind of snap the model and panorama into place. And as a result, this would accurately place the panorama cube into the model.
Most of the prototypes developed by the Bentley Applied Research Group could be modeled in this environment of directed browsing. And I know, having spent the last 3 months working on subjects like this, we're really excited to see what the future holds for this kind of technology within Bentley.